Good afternoon and welcome to the AMA Guest Speaker Series sponsored by Hobby King, and we're thrilled to have Dave Wigley with us, four-time Mr. Top Gun, and these two terrific models over here. He's going to go into some great detail about these, but also some of the cool airplanes that he likes to build. He's got some great advice and some great tips for you. So let me introduce Dave Wigley.
Thanks. Thanks very much, Jeff. Well, thanks for coming out, guys. It's great to be in the company of fellow modelers. I'm really honored to be here to speak to you today about what I've learned over the years that I've been scratch building models. And hopefully if some of you can take away some good points from what I have to say, then it'll be a worthwhile day. For you, those of you who don't know me, as Jeff said, I've been competing at the annual Invitational Top Gun Tournament in Florida every spring. And in 2010, 11, 12, and 13, I won the top award of Mr. Top Gun. 3 of those years with my Westland Wyvern over there with the yellow and black stripes, and 1 with the Bristol Beaufighter, which was the next project I did after the Wyvern. My current project is an F-101 Voodoo, 1950s. That was a interceptor. It's in 1/6 scale, so it's 11.5 feet long, and it's got an 80-inch wingspan. That is just the plug of the aircraft. That'll be the actual size of it. And once I finish doing the detailing on the plug, I'll make some molds off of that, and the molds will be used as the tooling to make the finished airframe. And once you've got the molds, you can make as many airframes as you like, as long as the molds last. So it's a tremendous amount of work to initially make the tooling, but once the tooling is done, it's relatively easy to make individual airframes. Some of you might remember some of the seminars that I did with Roy Valancourt up in Poughkeepsie a few years ago, so this is kind of a follow-on from that. We'll be talking about designing and building from scratch. I traditionally do larger scale, giant scale airplanes, but that doesn't mean any of these techniques can't be used for smaller electrics or mid-sized airplanes. And even if you're building from plans, you don't necessarily have to build from a blank piece of paper in a 3-view. If you're building from somebody else's plans or even enlarged plans, some of these techniques maybe will help you. It was interesting to listen to Julian and Dan's presentation there, especially Julian talking about what went into the X Prize competition. And of course, what we're doing here, building model airplanes, is not rocket science, but some of the things she talked about, like perseverance and you know, being innovative when you're designing and building stuff, that really helps. One thing I'd have to say about building a design from scratch, you really have to be passionate about the subject you choose. Now, whether that's, you know, because a family member flew on or worked on that type of airplane, or something you've always had a hankering to do and nobody's done plans for it or built it before, you really have to want to do it, because there'll be times in the process where you kind of hit a brick wall. You know, you think, oh, am I ever going to finish this? I mean, the Wyvern and the Beaufighter each took 5 years apiece to do, from design to completion. The Voodoo, I've been at that for, I've kind of lost track. I think it's 4 years now. So you really have to be passionate about the subject you choose, and you really have to want to see it done. And an important thing, I think, is that you have to avoid this temptation to think about, when will it be finished? You know, I really want to get it finished. You have to think about it as more of a journey rather than a destination. I have some slides here to start out, just as inspiration. Anyone know what that is? The Canadians here probably do. Avro-arrow. Yes, of course. Mark, you're not allowed to answer any of these questions because you know more about airplanes than anyone in this room. Anyway, Avro-arrow, that might be an interesting subject to do, right? How about a B-58 Hustler? I won't be stuck on jets all afternoon, I promise. Here's an interesting subject, a World War I subject. That would make an interesting paint scheme, wouldn't it? I don't think I'd want to be in a competition having a judge look at the stripes, though. How about a civilian Cessna Caravan? That'd make an interesting subject. Nice proportions with a nice high aspect ratio ring. Interesting paint scheme. It's fixed landing gear, right? But the nose is probably big enough for for a decent sized engine. You could maybe even make that an electric if you wanted. Plenty of documentation available on that airplane. How about that, a Boulton Paul Defiant? That'd make an interesting subject. Not a very successful aircraft. It was much the same size as a Hurricane, but it had that ball turret in the back here that made it very heavy and not very maneuverable. Interesting idea, but it would make an interesting model. Here's another one. I have a short list of airplanes that I'd really like to build, and this Henkel 219 Uhu would be, I think, a very, very interesting model. I'd probably do it about the same size as the Beaufighter, probably an 11-foot wingspan, and got plenty of room in the nacelles for engines. I don't know what you do about those wacky antennas on the front of the nose, though. That might cause you some sleepless nights. Let's see what else we got here. Oh, how about this? Anyone know what this is? Shut up, Mark. Yeah, that's right. It's the Pucara from, it's an Argentinian Air Force, an Argentinian design, actually. Very interesting subject. That's on my short list. Pretty simple retracts, although if you look at the size of those nacelles, they had turboprop engines with a very, very skinny spinner and engine housing out the front here. You'd probably have to make that electric. But that would make an interesting subject. Of course, the Lysander. Where's Rob Queso? He's working on one of those. And very, very interesting subject on that. How about a tracker, the Stoof? That would be an interesting one. I put that in for Roy. Anyone know what this is? I'm not looking at you, Mark. It's a TSR-2. It was another similar vintage to the Avro Arrow. This was a British design that fell victim to government cutbacks. It was cutting edge. It was a low-level strike aircraft. That would make a very interesting subject to do. No one's ever tried that. And finally, the Westland Whirlwind. I know Vance Mosher has plans out for this. I'd love to do this, but I'll get to it someday. Very interesting subject. Not a very common aircraft. You see a theme here. I tend to choose subjects like the Wyvern or the Beaufighter that nobody's ever done, and that's kind of my inspiration. No one's done a Voodoo before either, so that cuts me going. So some of the things you need to consider, I think, when you want to design an aircraft on your own, scratch build one, is collecting documentation. That's just a shot of my Beaufighter, but I'll talk about that a little later. Collecting documentation is very important. You need and these days it's relatively easy compared to years ago with the internet. You can just get on and Google the subject you want and spend days and months collecting documentation. What I've done in the past is if I see a magazine or a book that comes out on the subject aircraft I'm doing, I always grab that. If I'm in a museum gift shop and I see a book that a subject, even if I'm not too sure I'm going to do it, but I always grab it because you never know if that book will be around years from now when you decide it's time to get started. So I'll have, on my bookshelf, I have books and files from the various airplanes I'm interested in doing, and when I get inspired to do something else, usually after working 5 years on a project, I say, "Boof, I never want to start another subject," and then probably a month or two down the line, I start to think, "Oh, it's not so bad. I'll get going on something else, something new." So I drag out the file and start looking through it and get inspired and start to consider doing it. I think one of the first things to think about when you decide to scratch build your own aircraft is what size you want to do. Of course, there are considerations like whether you have a trailer or a van to transport it to the field, right? There's cost considerations, whether it's when you're within your budget. Those are some of the things that factor into it. On the Beaufighter, the considerations for that for me was I always saw when people build twin engine airplanes that unless you build them big, they tend to look very small. So even if, say if I built the Beaufighter to the same wingspan as the Wyvern, right, which is 100-inch, it would look like a small aircraft. So I decided to do the Beaufighter, and oddly enough, it turned out to be the same scale as the Wyvern, which was 1/5 scale, and it ended up being 138 inches, 11.5 feet wingspan. And I'm really, really glad I did that. Even though it's big and it's hard to move around, I was lucky I had a trailer, and there was some difficulty assembling at the field, but I'm glad I did it that size because it flies so realistically. And if you've got fixed weight for things like batteries and servos and receivers, So that fixed weight is going to go into a smaller airplane. Proportionately, it's going to add more to the weight, of the overall weight of the aircraft. A large aircraft, you got the same fixed weight is spread out over a larger wing area and larger size of aircraft, so it makes it easier. Not to mention, it's easier to install things when you got a larger aircraft. So that I think it has presence in the air too if it's larger to begin with. So talking about, you've decided on the aircraft you want to do, you've collected a bunch of documentation, you're all worked up to do it, and you've decided on the scale you want to do. One of the other factors that factors into the scale is what parts are available commercially that you can't build yourself. For example, tires, pilot figures, those kinds of things. Maybe retracts, landing gear, if you don't want to have to make them yourself. So that factors into the size consideration as well. But once you've got the size figured out, then you've got to start to design the structure. And these days, we're very fortunate that aside from having the traditional drafting board and French curve and vellum that we've used for years and years, there are a number of CAD programs, computer-assisted design programs, that are available online, and some of them are free downloads. So that's another way to work on the aircraft. The Wyvern I did the traditional way, the Beaufighter I designed the traditional way, but the Voodoo I actually used CAD to design that aircraft. I'll talk a little bit more about that later. So some sort of the things that go into designing an aircraft, whether you're going to, if you're doing a built-up structure, I find it's very helpful to look at a cutaway of the full-size aircraft at first. That'll give you an idea of what sort of structure went into the full-size aircraft and give you ideas where to do things. And this came really, this was really important for me on the Beaufighter, because initially, looking at the 3 view of the aircraft, I looked at the landing gear and I thought, oh, the landing gear, it's very similar to DC-3 landing gear. That shouldn't be too much trouble. It wasn't until I got looking at things carefully, and actually if you look at the cutaway here, originally I figured I'd be able to make a tubular, like a aluminum tube spar that would go right through the wing here, right? Well, it turns out that wasn't going to work, because just as on the full size, this forward spar and this rear spar define the size of the wheel well. And we'll see later how this wheel tucks up in there. There's really no room for a large, or even a smaller diameter aluminum tube spar. You really have to build it structurally as they did the full-size one, with a vertical web type spar at the front and back of the wheel well. Here's, you see what I'm talking about here. This is what the wheel looks like when it's retracted. You can see that here's the front spar here, right? And the rear spar is behind the wheel, and the wheel fills up that whole cavity right there. Here's the structure that supports the wheel, and this is the oleo. I'll show you some pictures right down the line here. If you look inside on this picture here, this is what the wheel well looks like when it's extended, right? And an interesting story here is, I mentioned, looking at the 3 view and looking at some pictures of the aircraft, it looked like a fairly simple landing gear. Well, it turns out, as usual, the British tend to take the simplest thing and complicate it to the nth degree. And I ended up going up to a museum up in Canada and sticking my nose up in the wheel well of a Bristol Beaufighter, trying to figure out just how this landing gear worked. And it's genius, but it's for a modeler, it's pretty complicated. And one of the things I noticed is, well, actually, what we get here, I'll try to explain a little bit. I'll back up here. Yeah. Okay, so you get your oleo here, right? And these are the drag braces here. And there's a pivot here that folds, and it goes over center. And it's attached to a torque tube here. But the funny thing is that this is your actuator cylinder here, right? And on the full size, that's a hydraulic cylinder. The full size we use hydraulics. And that cylinder on the full size is maybe only 3 or 4 inches in diameter, because you can get a lot of force out of hydraulic fluid, even at a relatively low pressure of, say, 1,000 psi. I considered using electrics for actuation. I considered using hydraulics, but I ended up discounting everything and went with pneumatics, because electrics, your actuator wouldn't fit, and even with pneumatics, if you take a look, you can sort of see it here. that top of that cylinder is within 1/8 of an inch of the top of the nacelle, on the top side of the nacelle. This is upside down, right? And in fact, that fitting there where the air hose attaches, originally I had it on the top of the cylinder, but I had to block that off and put it on the side of the cylinder because it just wouldn't clear. And the way the Brits designed this thing was, I guess the engineers said, you know, this is going to be the shape of the airframe, and this is how long your cylinder can be, so you design landing gear that will fold up into that area, and that's what they did. Yeah, the consideration about hydraulics for this was possible too, because I get away with a smaller diameter cylinder, but then when the wings disconnected from the fuselage, I'd have to have fittings that wouldn't leak hydraulic fluid, so that was out of the question. But I'm getting a little deep into a specific airplane, but what I'm getting at is if you're designing your own aircraft, you not only have to consider how you're going to design the structure so it's strong, but also how you can fit what you need in there, like landing gear. And if you're going to purchase landing gear units, you've got to figure out how those will fit into your airplane, how you build the structure to match with the commercially available units. Or, you know, I went a little overboard with this landing gear and did my own, so I had to figure out how to design that. Looking at a couple more cutaways here. Here's an example of the Wyvern. Again, very helpful in the design process. If you look at, you can look at the fuselage and see where the formers went there. Not that you necessarily duplicate that, but just an interesting point here on the Wyvern, the wing spar runs along the rear of the wheel well as opposed to the front for the Beaufighter, right? Of course, there's a small sub-spar here along the front. So when you're designing the structure in the wing, you have to consider things that are fixed in location, like the landing gear or the wheel well, and you work around those. So I ended up, on the Wyvern, I wanted to plug in outboard wing panels and on aluminum tubes. So I figured, okay, I'll put an aluminum tube on the front side of this spar here. But then when it came to going to the outboard wing, I had to put it on the back side of the spar. Otherwise, it would be too close to the leading edge. So that was another kind of design problem. The spar jogs, but the joiner is the spar, the tubular spar, and that keeps everything together. Another thing that's interesting on this cutaway is this detail over here on this side talks about the outboard flap here. And they also have a speed brake that sticks up on the top. So you can get a good idea, if you wanted to design that into your model, what it should look like just by looking at commercially available cutaway drawings or plans. Here's another look at another 3-view, and this is the only point I want to make on this, is this Yak Russian aircraft. Just because, see the spacing on the wing ribs there in the wing, you're not necessarily going to keep that same spacing on a model, right? What I find is helpful is I'll look at other designers' plans to get ideas, right? For Valley Aviation and Zeroli plans, to get an idea of what kind of spacing they put on ribs and formers in the fuselage, and just copy. They don't have to obviously have the same shape, but you copy the same spacing, and if it worked for them, it should work for you. When we are talking about transportability on the aircraft, it's kind of funny. When I was looking at the 3-view and the size of the Wyvern there, of course that fin is huge. It's probably twice as high as anything you'll see on anything else. And I thought to myself, well, if I'm going to be moving this fuselage up and down stairs and through doorways with that giant fin, for sure I'm going to smash that fin every time I do it. So I decided to design the fin of the Wyvern so it was removable. So what I did is I built in 2 carbon fiber rods, 1/4-inch carbon fiber rods here that are glued into the ribs of the fin, and they slide into tubes that run down into the sub fin here in the fuselage, and then through the wheel well I was able to put 632 cap screws that would hold everything together. Another interesting point for me is if you're building a scale model, and of course I fly in competition, so I want to look as realistic as possible, but I like to hide switches and mufflers and anything that's sticking out that's not to the original, and I kind of use that same philosophy here with the parting line here. I could have gone straight across, but on the full-size aircraft there was a construction joint here where the full-size fin was on, so I copied that position, and if you look over there on the model, you wouldn't know that that fin's removable unless I told you, because I did it along a construction line, and it kind of blends right in as to where things should be. Another thing that I find is really helpful during the design process is I start with a master 3 view, and this is the 3 view of my Bristol Beaufighter. Front view, top view, side view, and there's a scrap view of the rocket rails. Since I fly in competition, I would use this master 3 view to show the judges, right? But the important thing about this is I take the commercially available 3 view, I make a master, but I enlarge it up to 1/10 scale, and then I use my engineering ruler with 1/10 of an inch spacing on the engineering ruler, and anytime I want to check a dimension, right, I just lay the ruler against the side. If I want to say, okay, how wide is the fuselage here at its widest? It's 11 inches, right? How long is the fuselage? From here to here, 9.6 on 10th would be 96 inches long, right? How thick is the wing going to be? Oh, it's going to be 5 inches thick. I find that really helpful, and especially in competition where you want to build the model to match your 3 view accurately. If you're always working from a master 3 view and you always build the model to this, when you have the aircraft on the judging table at the competition, the judges are looking at your aircraft and they're comparing to this, but you've just spent 5 years comparing your model to this or building it to this, so you know it's accurate. And for me, I've been very lucky that way, that I get very high static score at competitions because the 3 view matches so correctly. But that idea of blowing up your 3 view, your master 3 view to 1/10 scale and using an engineering scale, or any scale you like, you could do it with centimeters or whatever works, but just being able to easily reference, you know, measure things. And I use this when I use this technique when I just draw the plans, right? It's very easy to check dimensions. Say the wheel, you know, you got to buy a wheel or something. What diameter you got to go with? This says it's got to be 7 inches. So that's really helpful. What I find helpful during the design process is rough sketches. There's the 3 view I was talking about on the Beaufighter. But here's a rough sketch that I used during the design process on the Beaufighter. I knew just from looking at the 3 view that there's no nose sticking out the front of that airplane, right? So a key design consideration making a Bristol Beaufighter, and that for me was the challenge, was being able to make that tail as light as possible, because if you didn't, you may end up not having enough room up front to be able to put enough weight to get the balance correctly for it to fly. So and I'll show some slides a little further down the line on how I managed to achieve a super light tail, but that was a focus that I kept throughout the whole project, was to keep the tail as light as possible. So during the design process, I said, okay, I'm going to have to put heavy things like servos and batteries up as far forward as possible. So that's what I ended up doing. I figured, okay, the only place to put those things in the fuselage, and if you notice here, I had this photocopied so that I could see through, almost like an X-ray view of the nose here, right, through the nacelle. So any batteries and receivers and servos that are heavy would have to go in this area here, under the cockpit. And here's a top view of my scribbles. And I came up with the idea that, okay, on the Beaufighter, since it's a twin, you're going to want redundancy on the rudder. So you're going to need 2 servos driving the rudder. How can you do that? Well, it turns out SWG has a mechanism, we'll see a picture in a second there, that will allow you to have 2 servos. If one servo jams, the other one will provide power. So I knew I wanted 2 servos, 2 rudder servos up front, right? And I figured, okay, I also want elevator servos up here to move them as far as forward as possible. So I put them on either side of the rudder. With carbon fiber rods going back to arms behind the wing here, and then push rods up this way. There's no way I was going to put elevator servos traditionally in the tail or rudder servos back there, because that would just add weight to the tail, and I might end up not having to be able to add enough weight to the nose. So what I'm getting at is this is the kind of design process you think about. Originally, I thought I'd have cables from the rudder to go to a torque tube arrangement here with arms that would transmit those cables from this push-pull to this push-pull up here directly back to the rudder. I ended up, when I actually built it, I took a sacrifice a little bit of weight for simplicity, and I had the cables run back to here, and then I had the little torque tube back here on the final version, and I actually didn't have enough room up in the nose, so I put the servos back here behind the rear spar. And here, that's sort of shown in this picture here. This is a picture of the Beaufighter fuselage upside down. This is the nose area here. The cockpit is through the bottom here. And this is what I was talking about, that dual rudder control. SWG sells that. And you get a pull cables here, right? No room for elevator servos here, so they went back behind. I took a little bit of a sacrifice, put them back behind the spar, and that wasn't too much of a hit. But what I'm getting at is it's just sort of part of the design process. You come up with a concept on how big it's going to be and where you're going to put things based on balancing the aircraft. And sometimes you have to modify it during the build. Here's another slide of what I'm talking about when it talks about building from scratch and lofting formers and ribs. Anyone know what the term lofting came from? Shipbuilding, right, exactly. Back in the old days, they would have these huge sail lofts down by the waterfront where they'd sew sails together, but they'd also use them to design ships, the shape of the bulkheads for the ships, and they would actually draw it out in chalk on the floor. So lofting is a process where you start with you want to make a smooth surface, and you want to have some structure inside, so you do what's called lofting of the ribs. And here is my master drawing for the formers in the fuselage, and I have a vertical datum here and a horizontal datum here. This is looking straight on at the aircraft. These are the formers that move from the widest part of the fuselage forward up to, this is where the radome is on the front, and these are the ribs that run down the tail towards, this is where the fin post would be here. So you, with the French curve, you run smooth curves around there, and then there's no reason at this time to draw a left and a right for all the formers, because you're going to use this as to trace through your drafting vellum on a larger sheet where you have all your formers laid out. You have vertical and horizontal datums, and then what I do is I'll slide this sheet underneath the vellum. I'll trace through around, say I'm doing this former here, right? I'll trace that through, right? And then I'll slide this sheet out, flip it over, and the vellum is thin enough that you can see through this line on the opposite side and trace that around there. And do that for all your ribs, all your formers for the fuselage on a separate sheet. You do it the same for all your wing ribs, right? And then you have a set of plans that you can cut out parts. If you want to send to a laser cutter, you can do that these days, or you can cut them out yourself from the bandsaw. But that's kind of the idea of building from scratch and lofting formers and ribs. An alternative to that, as I did on the Voodoo that I mentioned earlier, was using a CAD program. And this is a screenshot of the surfaced model of the Voodoo. This is only a virtual picture. This is not a picture. This is what the CAD program allows you to do. And you can rotate it around on the screen. It's really neat. You can look at the front, the side, any angle you want, and it looks real. But it's not until you spend another 3 years and you end up with that. But the advantage to CAD, especially with the design like a jet, where it wouldn't be practical to make that jet out of traditional built-up structure, because you've got engines that need to go inside the fuselage, right? You need to have ducting, you need to have exhaust pipes and things like that. And also you want a very, very strong structure that's also very light. So that lends itself to a hollow type composite structure. So the process on the Voodoo, if you're interested, is I went from this, and then I imported that program into a router, a CAD router. It's actually a guy on Long Island who makes surfboards, and I rented some time on his machine, and this is actually the tail section of the aircraft. This area here is where the afterburner would go in here, and this is the tip of the tail where the drag chute is. And this is the gantry. The router is about 8 feet long and about 4 feet wide, and this is a 5/8 end mill, ball end mill, and it routes that foam in no time. I think it took maybe 20 minutes to route that whole thing. So I do each side of the tail would be in two halves, right? The center fuselage, I think, was a top and a bottom, and the front fuselage, it was actually in three sections, was a left and a right. So after that process, then the fun begins. You get to put it together and make it look like a voodoo, but that's all it does is look like one. And you can see here that there's no fin on it, right? I have some wingtips out here, and there's no stab yet. But what I ended up doing was hot wiring this area and hot wiring the wingtips. You'll see that in this picture here. And here's, for example, is the right-hand wing, and this is sheeted with, I actually use very thin plywood because veneer, because I wasn't worried about weight. This wasn't going to be the flyable piece. This was just going to be a plug that was used to make a mold. But you can see you fiberglass all the pieces. This is, oops, I'm moving ahead here with myself. This is the afterburner can. This is actually the aft fuselage with the fin, right? This is the mid fuselage of the front fuselage with the canopy, and that's one of the wings there. So, you know, it's quite a lengthy process, but the stage I'm at now is putting detail on that plug, and after that the molds will be made and the finished product can be made. Here's an example, just backtracking to a traditional built-up structure. This is the Beaufighter, and again, focusing on keeping the tail as light as possible. Normally in a traditional built-up structure, you have a crutch that supports all the formers running down the back, but that was out of the question for the Beaufighter because any extra structure back there that wasn't going to contribute to the strength of the airframe was just wasted weight, and it could cause me to have trouble when I needed to balance the aircraft. So what I did was I dreamed up an external crutch, and what that was is these 1x4 pine boards, one on each side, and then I added these support structures here, these little angle pieces, and they actually support this one stringer down each side, the only 1/4 by 1/8 stringer. And what I was able to do was add the formers, right, to the stringers and glue them on, and then I would sheet the top of this all the way down to here, and then I was able to remove the fuselage from the external jig and sheet the bottom without any twist being built into it. So I ended up with an optimally lightweight structure that was the best I could do for the tail end. Another interesting note on this picture is these bulkheads here. This is, of course, support for the horizontal stabs and the fin. The horizontal stabs in the Beaufighter have dihedral to them. So there was 2 of them here, and normally you'd make those out of plywood to make them strong, but that wasn't a factor here. Again, saving weight, I ended up using end grain balsa, 1/8 end grain balsa, and laminated carbon fiber on both sides of the end grain balsa, and I ended up with a structure that was super, super light, but stronger than plywood. And I did that with both this former here and this one here. And another interesting thing is when you design, try to get structure to do more than one task. So here, this bulkhead or former here was also the attachment point for the tail wheel landing gear. The tail wheel retracted forward on this airplane, so I mounted it. I designed it so that this was not only supporting the stab and the fin, it was also supporting the tail wheel. Avoided any extra weight, any extra structure in the back. Beat you up one more time on keeping the structure light. This is again another picture of the tail area on the Beaufighter, and this is an example of the skin that I use. This is something called flight skin. It's a very, very thin fiberglass skin that comes in rolls. It's only about 7 or 10 thousandths of an inch thick, but it's very smooth. You glue it to the structure with medium zap, and it's super strong. You build a traditional balsa wood structure underneath and put this on. And the beauty of this is that it's pre-finished. You can put paint right over that. You don't have to fill in sand and paint or do anything like that. The only downside to it, it won't go around compound curves. It will only curve one way. So what you have to do on the leading edge is I ended up using chrome tape for the leading edge to make it look smooth and make it look like a metal part there. And the other point here on this slide is this mechanism here is the torque tubes for each elevator half coming down to arms, and the rods go forward to the servos that are up further forward in the fuselage. So here's something else to talk about is you got to, I mentioned considerations for when you scratch build an aircraft, whether you'll be able to get commercially available pieces and parts. That applies to pilot figures and wheels and retracts, but it's not likely that you'll be able to find a canopy that's the correct size that you need. So this is an example of a process used to make the canopy for the Wyvern there. You start out with a foam plug that's glassed and sanded and polished, right? This is actually the plug that I used. And then you lay up fiberglass over the top of that and you end up with a mold. This is the mold with a cavity down here. And inside that mold you pour casting resin that's going to be used for your final plug that you pull, vacuum form a clear plastic canopy over. There's no way you could vacuum form over this because the heat and the pressure of the vacuum forming process would just crush everything. So you need something of uniform density and really strong to do that. Oh yeah, this is just to finish up. This is if you're interested in what goes into the front of that Wyvern. I knew that the design challenge for the Beaufighter was keeping the tail light. The design challenge for the Wyvern was the Contra-Rotating Propellers. The full-size aircraft had 2 4-blade propellers, so a total of 8 blades out there spinning around. And I wanted to, you know, in video or in pictures of the aircraft flying in the air, I wanted to get that illusion of a lot of blades spinning around. So I designed this. First of all, I had to extend the prop shaft out 6 inches from this standard gas engine, BME 100. I decided to make the front propeller, or excuse me, the rear propeller driven by the engine, but the front propeller was just going to windmill. So it would give the illusion of many blades spinning out front. And these are all the pieces that go into that structure. I started with the engine here. Here's the extension shaft. How do you hold the extension shaft to the engine? Well, you need a steel rod down the middle, right? And then how do you hold the propeller on? Well, you got a nut that screws on here, and then you got another sub shaft out here that holds the windmilling propeller on the front. How does it all go together? Well, you're going to have to support, you can't have a 6-inch shaft out the front of your engine. That won't work. So you're going to have a box or some sort of structure that supports this. Here's the box structure here. So the engine bolts to this back plate. This box structure bolts to the back plate as well. And the shaft runs through the middle. Here's a support for the front bearing that screws on the front of this plate. The spinner goes on, propeller goes on, it's screwed on, front propeller, good to go. That took a lot of testing, was a lot of fun. So yeah, just to wrap up, final picture of the Beaufighter in flight. Could be the real one. Yeah, I think you know, designing and building from scratch can be very, very satisfying. It can be frustrating at times, but I think that the rewards are well worth the effort. Again, you got to be passionate about the subjects you choose. You got to really want to finish the project, because there'll be times when you hit a brick wall and you really think you'll never finish it. And the best thing I found to do right then is think of it as a journey, not a destination. And it's kind of like eating an elephant. It's one bite at a time. So just take each task, you know, treat it as a number of smaller tasks instead of a huge project. Anybody have any questions? Oh, wait a minute, we've got to get Jeff out here. Where's the microphone? There he is.
We talked about designing the tail,
Right.
weight versus strength.
Right.
You just kind of get a feel for that, knowing how to balance those two issues from experience?
Right. Not talking about a specific airplane, but again, I think referring to how other designers have built tail structures. That helps when it comes to designing things, rib spacing and spars and stuff like that. It was tricky on both the Wyvern and the Beaufighter for me because it has dihedral. Whereas if you have a straight stab across the back like a Spitfire or Hurricane, something like that, if that's the subject you're choosing, it's fairly easy to make it as a single piece and slot it into the fuselage just like a regular designer would.
How do you simulate rivets and skin lines?
Oh, well, that'll be the subject for next year. I'm just kidding. It depends if you're doing raised rivets or flush rivets, right? Traditionally, raised rivets, you'd use a syringe with glue drops, right? It's just regular white glue. That'll give you the bump. Flush rivets are usually done with a small brass tube, maybe an 1/8 or smaller in diameter, that's sharpened, and you put that in a soldering iron and you just press it to the structure. That's, you know, all these techniques that you know, it's great to come here and listen to someone like me who's done it, but also we're very lucky on the internet now. You can go to all these RC groups and find different ways and different techniques to do things, and try them out yourself, you know, see what works for you. What I've learned over the years building the models is that you see what somebody, ask what somebody else has done, as you did, right? Go home, try it out. If it doesn't work, ask somebody else or try something else and get a technique that works for you. Interesting, you should ask about the rivets, because on the jet there, I was considering using the hot brass tube method in the soldering iron, but I'd heard that what most of the jet people do now is you take a Dremel with a drill bit that's the correct size, and you cut that at an angle so it has a sharp edge to it, and you just touch it to the surface and it cuts a circle every time you cut a rivet. I've tried that and it worked great because the tip doesn't clog with glue or anything, and so far it's worked good on, I don't know, probably the 500,000 rivets I've done on the Wigley so far. Thanks.
Thank you.
More questions?
Come on, Sal, you're dying to ask. Just turn the microphone off.
I said I taught him everything he knows.
Oh, Sal. Bob Boswell, another master modeler.
I wonder if you could elaborate on your secret to documenting your aircraft for competition.
There's no secret. That's an excellent question, Bob, and a good subject for another seminar, but I'll try to breeze over it. In competition, I think you have to think of it, you have to really put yourself in the judge's shoes, right? And for those of you who don't fly competition, there's always a static score, right? And there's always a flying score. So whether you're in front of the flying judges or the static judges, you should sure put yourself in their shoes. So what you want to do when you put together, for example, a documentation package for the static judges, you've got to have a 3-view, you've got to have documentation on color, and you've got to have something about craftsmanship. So, for example, on your 3-view, on this Beaufighter 3-view, I cleaned up a lot of this, right? On the one that was published, there are a lot of extra cross sections of the fuselage, and there are a lot of scrap views of various things. But you want to give the judges something that they can look at easily, refer to your model easily, and shows it off. And if you look here, I have a number of ball notes on here that refer to deviations. So, for example, I think number 4 here had something to do with this piece sticking down here. So you make it easier for the judges to reference what's on your 3-view as to what's on the airplane. The other, so yeah, and the color chips, right? You're going to want to add those and play up your craftsmanship when you're talking to the judges about what things you've done, right? Many guys will present their airplane and just sort of stand back and, you know, think of the judges as people you want to be careful talking to. They're modelers just like you are, right? And they're interested in what you've presented, so do a bit of showmanship and show them what you're interested in. That's the static end of things. Just to talk briefly about the flying end of things, I think what's important is the flight plan that you choose, right? In competition, you've got to do a certain number of mandatory maneuvers and a certain number of maneuvers that is your choice, right? So, for example, that's one reason why in competition with the Wyvern and the Beaufighter, I have a torpedo drop, right? Because it's something that they don't always see. A lot of people think that it's a very easy maneuver to get a top score on because all you have to do is flip a switch. Well, let me tell you, it's not that easy. It's very critical that you're at the correct altitude, the correct speed, you drop it at just the right point, because if you're too low, there's a risk that the torpedo will hit the ground and come up and hit the airplane, and then that's the end of your perfect 10. It's probably the end of your airplane. And if you drop it too high, the torpedo will nose over and hit the ground like this. That doesn't look very realistic, right? And also, the drop mechanism had better work 100% of the time. Because if you fly by and you want to drop a torpedo and it doesn't release, you just went from a 10 on that maneuver to 0, and you probably lost your competition. So yeah, choose maneuvers that are prototypical, choose maneuvers that have a bit of wow factor, and again, just to wrap it up, Bob, having an airplane is different, you know. I wouldn't have won Mr. Top Gun 3 times with a Wyvern if it was a Spitfire, because the judges are sitting out there in the hot sun for days on end, and you show up with a Spitfire or a Thunderbolt or something, and I don't care how big it is or what cool the paint job is, they still look at it and subjectively they say, oh, another 347. Whereas if they see a Wyvern, they say, ooh, this will be interesting, and they pay attention, and they're subconsciously likely to score you higher. Anybody else?
It was a great presentation.
Thanks.
You talked about lofting.
Yeah.
And tree views and looking at fuselage formers. Depending on the subject, you might have a very curvy fuselage.
Curvy?
Yeah,
yep.
like maybe like an F4 Phantom where they had the Coke bottle.
Right.
So it dips in and out.
Yeah.
I mean, do you ever look at a subject and you say, well, if I put a bunch of formers there, you know, it's going to add to the weight. And,
right.
you know,
right. Yeah.
It's a little too much.
Yeah,
Maybe
I see what you're getting at. I understand. I see what you're getting at. And again, that's one reason why the Voodoo and jets don't lend themselves to a built-up structure for that reason, right? They have funky curves, and you're probably better off. And you know what? Just because I used a CAD program to cut that foam doesn't mean you can't. For example, Lance Campbell built that SR-71, right? And what he did was he got a long steel tube, right? And he cut out formers that were cross sections that he lofted. He didn't use a CAD program to do those, right? And he stacked foam in between those formers, right? And he just sanded down to the formers. You don't have to use CAD to design an airframe. You can do it just by simply hand sanding, right? And once you've done that, and the same works. I mean, we're talking about airframes here, but the same thing works for cowls or drop tanks or torpedoes or stuff like that, right? So getting back to your question, if you were going to do an F4, for example, right, I wouldn't do a built-up structure on that because it would be too crazy to do all the curves, right? I would do a foam thing with molds, right? What people sometimes do is they'll if they want to do just one, right, they'll make a foam plug, they'll fiberglass over it, and then pour gasoline down and dissolve all the foam, and you've got yourself a structure. There are different ways to do it, but that's a great question. Thank you.
Thank you.
Yeah, pleasure. Anybody else?
Any more questions for Dave?
Thanks very much, guys.
Great, thank you, Dave.
Thank you.